Assalamualaikum and hi everyone. Today we want to present about experiment 5, which is frictional force. Let's go to the objective of this experiment. Objective of this experiment is to determine the coefficient of static friction of this different surface. Let's go to the theory of this experiment. Force and velocity are vector quantities that have both magnitude and direction. Velocity is the speed in a specified direction with which a given object is traveling. Force exists when the object accelerates or undergoes a change in its velocity. Gravity is an attractive force that exists between two masses. The gravitational force that acts on an object on Earth is approximated as Fg equals to mg, where m is mass and g is gravitational acceleration. Static friction is force that must be overcome in order to move a static object. Fs max equals to mu Sn. Kinetic friction is friction that acts on a moving object, and the kinetic frictional force is given by Fk equals to mu Kn. Let's go to the apparatus. Wooden block, rubber covered on one side, 50 gram masses, 10 Newton spring scale, and string and tabletop. This is the setup for this experiment. Let's go to the methodology. Number 1, the mass of wooden block had been measured and recorded as m. Number 2, the apparatus had been set up as shown in figure 5.2. Number 3, made sure the tabletop was stable and horizontal to the ground. Number 4, the spring scale and the wooden block were attached with a spring and were placed horizontally on the tabletop. The rubber side of the block was made sure to be faced downward. Number 5, Am equals to 100 gram mass was placed on the wooden block. Number 6, the spring had been pulled slowly. Once block start to move, the spring scale's reading had been recorded. The value was recorded as F and tabulated in table 5.1. Number 7, step 4 until 5 were repeated for 3 trials. Step 8, step 1 until step 7 repeated by make the rubber side of the block was faced upward. The data tabulated in a table. This is the video for the experiment.
Okay, Assalamualaikum, my name is Iman. Today I will continue a video presentation. Okay, if you see, this is a result of a rubber surface and non-rubber surface toward the floor. Okay, for the question 1 for analysis, draw and label the free body diagram of the wooden block. The free body diagram have a weight, mass, force, and normal force. Question number 2, plot the graph of static frictional force, Fs against normal force and for the rubber surface and non-rubber surface. The first graph is a rubber surface graph, which is the y-axis is a force and the x-axis is a weight. And for the non-rubber surface is the same, the y-axis for the force and x-axis for a weight. Question number 3, use a gradient orbital for the graph and calculate the coefficient of static frictional, ms for each surface. The final answer of rubber surface is 1.10 and for the non-rubber surface is 0.49. Okay, For the question number 4 is compare and discuss the coefficient of static frictional orbital. The answer is, based on the graph, the coefficient of static friction for a rubber surface is greater than the coefficient of static frictional for non-rubber surface. The coefficient for the rubber surface is 1.10 and the coefficient for non-rubber surface is 0.49. The reason is because rubber surface has a rough texture. This is increased surface area in contact lead to more intermolecular force between the surface, resulting is a greater resistant motion. For question number 1, how can anti-lock brake stop a car in a shorter distance than regular brakes? The answer is, when stopping, if the wheel lock up, kinetic friction is used to slow the car down. However, since static friction is larger, when anti-lock brake is done is to pump the brake so that the tire do not experience kinetic friction but static, which is turn slow the car faster in the shortened distance. Question number 2. From the experiment, which material has the highest coefficient of static friction? Does disagree with your hypothesis? What do you think determine the coefficient of static friction? The answer is, from my experiment, rubber surface has the highest coefficient of static friction. Yes, it is rough the surface, the higher the friction will be. The material determine the coefficient of static friction. For the last question, once the mesh begin to slide, does it move smoothly, or does it undergo stop and go motion? Explain the motion. The mesh undergoes stop and go motion because of friction. The velocity is decreased. The discussion for the experiment is, in this experiment, the frictional force between a wooden block and the rubber surface on a horizontal and inclined plane will be measured. And from the plotted data, the coefficient of static frictional will be orbital. Based on the result of the data sheet, we can see that the mass of the wooden block with rubber surface increase. The average reading of static frictional will also increase. Then, 2 attempts are being made to obtain an average reading. Despite the percent of errors such as a random synthetic error during the experiment, we can avoid it by finding zero error in the instrument. The eye must be perpendicular to the reading scale on the spring scale once the block start to move. In conclusion, in this experiment, we investigate the relationship between frictional force and the normal force acting on an object. The result confirms that frictional force is direct proportional to the normal force, as described by the equation, where is the coefficient of frictional. We calculate the coefficient of static and kinetic friction for various surfaces, and our experiment value were consistent with theoretical expectation, with some percentage error. The small discrepancies observed were likely due to measure inaccurate surface irregularities and human error during data collection. Overall, the experiment successfully demonstrate the principle of frictional force and highlight the role of surface texture and contact area in determining of coefficient of friction. That's all from us. Thank you.